So the new topic is on series, and this first lesson is just on general series and also sigma notation. So in this first example, we are given a formula for the nth term of a series, which is 2n plus 2, and we need to find the first three terms. So that means when n equals 1, when n equals 2, and when n equals 3. So let's just substitute those in, and there's just new little notation. T1 means the first term. So that's going to be 2 times 1, which is 2, plus 2, which is 4. So the first term's 4. The second term is going to be 2 times 2, plus 2. 2 2's are 4, plus 2 is 6. So the second term is 6. And the third term is going to be 2 times 3 plus 2, which is 8. So therefore the series is 2. Oh, sorry. The first term there is not 2. The first term is 4. And then we've got a 6, and then we've got an 8. Okay, so you can either write it like that or with commas. But we're going to be adding up series like this in a couple of lessons time, so either way. Next example. We're given a formula for the nth term, which is 6n minus 4, and we have to find which term is equal to 104. So we're going to make 104 equal to 6n minus 4 and solve that equation for n, because n is the number is the term number. So dividing both sides by 6, and you get n equals 18. So therefore the 18th term is going to be 104. And example here, find the first positive value of the series with nth term given by that. So the first positive value, oops, didn't mean to cross it out, underlining it. So that means we want negative 35 plus 3n to be positive, which means greater than 0. And let's solve this to find what n has got to equal. So dividing both sides by 3, you get 35 divided by 3, which is 11 2/3. Now remember, n is the number of the term. Like n is 1 is the first term, n equals 2 is the second term. So n is always going to be an integer. So if n has got to be greater than 11 2/3, the first integer after 11 2/3 is 12. So the 12th term is going to be positive. And you can just double check that by substituting in n equals 12 here, and you'll get a positive value for the term. And if you substitute in, say, n equals 11, you'd get negative 35 plus 33, which is negative 2. So you can see that 11th term is still a negative term. And find the first positive value. So the 12th term is positive, so we want to find what that 12th term is. So let's find T12, which is going to be negative 35 plus 3 times 12. 3 times 12 is 36, minus 35 is 1. So the first positive term is 1. Okay, then into sigma notation. Now, this little diagram is in your book, and it is a little general formula for you for finding the number of terms in a series. So the little sigma is saying the sum of all the terms, starting with the first term, which is k equals 1, all the way up to when k equals 5. So we're just going to substitute that. K squared minus 1 is like the formula for the nth term. So let's substitute in k equals 1, and we get 1 squared minus 1. So that's the first term. Now sigma means sum. So we're going to add that to the second term, the third term, the fourth term, and the fifth term. The second term is going to be 2 squared minus 1. The third term will be 3 squared minus 1. And the fourth term is 4 squared minus 1. And the fifth term is 5 squared minus 1. So we're just going to add up all of those, because that's what this is saying. This is the sum of all the terms, starting with k equals 1, which was this one, all the way up to k equals 5, which is that term there. So we'll get 0 plus 3 plus 8 plus 15 plus 24, and that adds up to 50. Now, if using this little formula up here, if a question said how many terms are there in this series, it's going to be p minus q plus 1. So here would be 5 minus 1 plus 1, which is 5. And you can see that there was the 5 terms in that series. And that's it for our first lesson.